Hello, I'm Paul Kirschner. I work at CellStack, the Center for Learning Sciences Technologies. In the next half hour, I'll try to give a good overview of what it means to write a scientific article, how you write a good scientific article. In another webinar, I'll be presenting how to get that scientific article published. You have to remember I'll be dealing primarily with writing an article within the domain of the educational sciences, the learning sciences. So keep that in mind because it's sometimes fairly specific with respect to that area. One of the most important things when you write a scientific article is that you don't plagiarize other people, and if you make use of other people's documentation, that you also give them credit for it. I won't be reading it, but these are a few of the sources that I made use of to make this PowerPoint presentation for you. I think the most important way to begin and to structure this whole talk to you is based upon the structure of a good manuscript. You can see here the major topics within a manuscript. There's a title page, the abstract, an introduction, the body of your article, the results, the conclusions and discussion, your thank yous or acknowledgments to other people, your references, and figures and tables. I'll be going through all of those different parts one by one, and for most of them I'll be giving you do's and don'ts, or you could say what should be in it and the most commonly made mistakes. If you look at an article, at a good article, you'll see that there's a funnel shape to your article. Your introduction begins rather general in scope, then gets down towards the particular in which you give your research questions and your hypotheses. Your body of your research, with all of its different parts, are all particular to your research questions and your hypotheses, the methodology that you used and things like that. Finally, in your discussion, you work in the exact other way around of a funnel. You begin actually particular, what did we find, and you end up fairly general, and what does this mean for the field, how can we go further? Here you see on the right-hand side the exact same thing, but with all of the different parts, including your reference. Okay, here's kind of the simplest thing, the title page. It consists of 4 or 5 parts. Usually a journal will want a running head. A running head is 40 characters or less giving the gist or what your article is about. There's the title, we'll get into that in a second, what a good title is. The authors in the proper order, their affiliations, and who the corresponding author is. Who do others have to get in touch with if they want more information or to comment? Okay, the title. I said I'd get into it, now I will. A good title tells the reader exactly what the paper's about. It's what they go to, they look at, it's the door to your article. It has to say something to get someone to really want to read it. It has to be concise, yet at the same time comprehensive. Concise, short, APA says 12 words, but comprehensive tells exactly what's in your article. That's not simple, but it's very important. And it needs to be consistent with the abstract and the manuscript. A bad title is really bad. If you say it's the doorway to your article, if you have a bad title or a misleading title, it will influence the editors and the reviewers negatively. It will give them an idea of what they should be finding, but possibly don't find. It can also put them to sleep. That this is a run-of-the-mill, the same old stuff that they've already read quite a lot about. A bad title also fails to attract an interest from the readers who would actually want to read your article. It's kind of like, what will someone look for and find if they Google you or they do a search? Or you could say a bad title draws the wrong audience. It draws people who are looking for something different and stumble upon your article. Sometimes that can be good, but usually that's not good. The bottom line here is a bad title is costly. It will wrongly influence your editor and your reviewer. It won't attract the people you want to attract. And the people it does attract will probably or possibly be the wrong audience. After the title page, the cover sheet, we have the abstract. All journals have different rules, but generally an abstract is a summary of the manuscript in approximately 200 words. That's not very much. In those 200 words, you have to cover usually 5 different topics. You have to discuss what was the problem that you investigated. You have to discuss why did you investigate it? Why are you doing that research? You have to tell something about the methods. How did you do the study? You have to tell the most important results and also the conclusions that can be made based upon your article, your research. If you look at that, that's 5 parts and 200 words, so you can say maybe you have 2 or 3 sentences for each of those parts. A second important aspect, not only of being a summary, is that that summary has to be able to stand alone and be published separately. Most journals on their web pages present the title, the authors, and the abstract. That means when someone is looking at the journal's web page, they have to be able to decide, based upon your abstract, if they want to read your article. So it has to be a standalone, because it will be web published separately. And finally, here's where we differ, or scientists differ. I always say write your abstract last, because you know what you've said in your article. Other people say write it first and use it as a guideline for writing your article. You can choose. My experience is that writing it last is the best way to do it. But of course, that's an N=1 study, and that's my own study. Now, what are the common mistakes that we make, that one makes when writing an abstract? The first is they try to give too much background or too much information about the methods. You have a whole theoretical introduction to an article to do it. The most important thing here is the basis. What is your major starting point premise for doing your research? The second is that people try to put figures or images into the abstract. That might be good for a web-based article, but for a paper-based article, that's not the best idea. Also, you see some people putting references to other literature, figures, or images. As I said, it has to stand alone. An abstract doesn't have a reference section or a bibliography attached to it. So you can't give a reference there because no one can find where the reference is. Finally, try to not use abbreviations or acronyms unless they're commonly used abbreviations or acronyms. If you've done an analysis of variance, you can write down that you've done an ANOVA. Everyone will understand that. But try not to use particular acronyms that haven't been discussed. After your abstract, the beginning of your article is your introduction. The most important thing to do is to tell your readers what's the problem, what are you trying to solve, what are you trying to achieve. You might say your unique selling point, but actually I prefer to use what is the reader's unique buying point. Why is the reader reading this? Why should the reader read this? Why should your reader buy into it, into your ideas, your research? Further, it gives broad information about the topic. You remember what I said? It's a funnel shape. You begin with broad information on the topic. You give the previous research that has been done in the field, eventually leading to why your research is unique and different from the previous research. You begin to get narrower and give narrower background information, which you need for your hypotheses. It's theory-based, and you finally end, so you put the theory into it, and you finally end with what the hypotheses are and what the research questions are. Most journals at this moment need you to explicitly give your hypotheses between square brackets. This is hypothesis 1, this is hypothesis 2, this is 2A and 2B, and they want you to refer to that in that way throughout the rest of your article. And something that's important to remember, it's the mirror image of the discussion. That means two different things. That means, on the one hand, your discussion will start very particular and go to the general, hypotheses, what this means for the theory, going towards broad information, returning to what are we going to do with this. But also, you should have almost nothing in your introduction that you will not discuss in your conclusions and discussion section, and you don't discuss anything in your discussion and conclusion section that you don't handle, that you don't discuss in your introduction. What are the most common mistakes? The first, and I must say I'm editor of 2 different journals, I review or am on the editorial board for maybe 15 or 20 other ones. I have a lot of PhD candidates writing research papers. The first thing is the cliche opening. Internet has made incredible changes in the way we blah, blah, blah. I've been reading this for 18, 20 years. Don't start with the cliche. Your reviewers have read that cliche so many times. By starting it that way, the first thing you're going to do is turn them off. They're going to say, oh, another one who doesn't know how to start a paper. A second, not enough or too much information. It's kind of like saying, how long do your legs have to be long enough to reach the ground? You need to give enough information that you are theoretically grounding your research, but not so much that someone says this is nothing more than a literature review. A third common mistake is that the purpose is unclear. It's not clear to your reader why you're doing this study. If there's so much research that's been done and so many results that have been obtained, why are you actually doing this? So if the purpose is unclear, people will read it and say, so what? That's the wrong thing for your reader to think. Wrong for a reviewer, and wrong if it ever gets published. Another one is if you want to tell quite a lot but you don't have enough room, people begin to make lists, make use of bullets. An introduction should be a piece of prose text. Only make use of bullets when the prose text isn't enough. If you want to try to put 7 points in one paragraph, then it's good to use bullets or numbers. It gives exactly the way it is. Also, if the structure is confusing, if it doesn't have this funnel shape and continues to be broad, get particular, get broad, go narrow, in and out, the confusion starts and your reviewer will lose your stream of thought. Finally, don't use first-person anecdotes. This is a theory section. Your research is based in theory. A good colleague of mine says data is not the plural of anecdote. Your introduction is not the place for first-person anecdotes. Having completed your introduction, you now reach the point that you write down your methods and your materials. The order here is a general order. It's not always done in this way, but usually we begin with the participants. Who were the people who took part in your research? That's followed by the procedures. How did you carry out your research? The materials that you used, questionnaires, tools, things like that. The tools and equipment that you used. Your data analysis techniques. Usually it's sufficient if you've used very traditional techniques or well-known just to mention it. It's important in this part of your data analysis techniques also, if you use throughout your whole research the same statistical tests and you use the same level of significance and things like that, to mention it once here so that you don't have to mention it at every time you present your results in the next section. And any computer programs used. As I said, this is a general order. Sometimes, in order for your readers to understand the procedures, you first have to tell them what tools you used. Because if you used a unique computer-supported collaborative learning environment in which certain interfaces were there, if in the procedures you say that the participants first had to do this and then had to do that, but they don't know what the tool looks like, they won't understand what you're doing, so you might have to first present the tools or the equipment that you used in order to have them understand the procedures and the materials. Sometimes you'll have to put the materials first if the specific tests, questionnaires, and things like that are important for understanding the procedures. But in any event, these are the parts of it. Remember, this whole methods and materials section does nothing more and nothing less than provide your reader with information on what you've done and how you've done it, and it provides information on how to repeat the experiment if someone else wants to do it. Now, what are the most common mistakes? Of course, the first thing is too little information. Not enough information for someone else to replicate your study. That doesn't mean you have to include all of your questionnaires. That's why there's a corresponding author on the title page so that they know who to get in touch with if they want to make use of your tools. A second one is providing information that should have been in the introduction. The methods and materials section is not the place for presenting theory. That's the place that you say why you chose certain instruments, certain variables, based upon the theory that was in your introduction. A third mistake is that you say too much, that you're ambiguous, that the person doesn't really know what you've done and why you've done it. And finally, sometimes people report the results or sources of error within their methods and materials. That's not the place to do it. If you talk about your participants and who they were, and you then say, okay, they were 6th graders, and this was their average age, and it was done there, all of the other information that's normally in the general descriptives that you want to say, okay, the groups were the same, you present that at the beginning of your results section. You don't put that in your participants section. After reporting what you've done, you present your results. That's an objective presentation. You give a summary of the data collected and the statistical treatment. You present only the relevant data. You might have quite a lot more data than what you actually need to present your results, because sometimes you'll have a quantitative and a qualitative, or the research that you do will lead to 2 or 3 different articles. You don't have to present everything here. You only present the relevant data. You make good use of tables and figures with references. I'll get into that. And it is not a conclusion, and it is not a discussion. It is the objective presentation of your experimental results. Now, what are the most common mistakes in the results? That raw data is given, and only raw data, and not the statistical treatment of that. So you don't know if something is statistically significant or not. Redundancy, presenting the exact same thing, paragraph after paragraph. We used an ANOVA with this and that and the other thing. Don't consistently repeat the information. A discussion or an interpretation of the data. Saying that a result is noteworthy means you're already making a judgment about it. It's no longer the objective presentation. You're interpreting your data in that way. The results section is not the place to say if something is noteworthy or not, or something that was unexpected. You do that in your conclusions and discussion. A fourth common mistake is either that people use no figures or tables, or too many figures and tables. An example of using none is that all of the numerical data is given in prose text. If someone wants to compare the means of 2 different groups, the best way to do that is to present it in a table. Other things is too many tables, so that you don't know what is important or what isn't. You use a table to emphasize and make things clear. Too many means you can't emphasize everything. Not everything is incredibly important. Giving lots of numerical information as text. Reading paragraphs that are only composed of a comparison of numbers, you'll lose your reader. And finally, of course, presenting methods and materials information in your results. That's not the place for it. The next is the conclusions and discussion. Here is where you interpret your results. You begin with, did the study confirm or refute the hypothesis? So you begin with what you meant to study. Don't rehash everything you've done, including the theory. You studied something, you ended, as I said, your introduction with your research questions and your hypotheses. You begin your conclusions and discussion with whether or not you confirmed or refuted the hypothesis. If you didn't, did the results provide alternative hypotheses or explanations? What interpretations can you make from the data, from your results? Do the results agree with other research? Remember, in your introduction, on your way in this funnel, you discussed other research. Have you strengthened the research of others? Have you found the same things? Have you found certain things that were different or specifics that the others didn't find? Why are you so unique? Then you go further in this upside down funnel to what are the implications of this study for the field, and you end with suggestions for and improvements or what type of future research should be made. If I want to say this in a joking manner, I'd say we have to keep ourselves in business. You always have to end with what's the next piece of research that someone else should fund that you can do because you've done this great research, but there are still some open questions that have to be answered that are really important. I can't emphasize more that you deal with the relation to previous research. Unless you're doing earth-shattering research that no one else has done before, give the relation to the previous research. How it extends, how it expands, how it's different. The reader should come away knowing this is where I can place your research, and this is why it's been so important. Now, what are the most common mistakes? People beginning with 2 paragraphs recapitulating their study as a whole. Your reviewer, your reader, does have a certain amount of short-term and long-term memory, and they remember what you wrote 3 or 4 pages earlier. So you really don't need to recapitulate your whole study. As I said, begin with your hypotheses, your research questions, and what your results show. You don't have to recapitulate the results. They just read that 1 page earlier. You have to tell them why the results confirm or refute the hypotheses, how they answer the questions. Giving new or not reported results. You can't discuss anything in your discussion section, any results, that you did not report upon. It sounds very simple, but I come across this constantly. Broad statements or generalizations. This is not the place for waxing prolific about everything and anything. You're going from specific to general, but remain within the scope of what you studied. Another thing is incorrectly discussing inconclusive results. You don't discuss non-significant results. If the results were not significant, they shouldn't be reported in your results section, and you should definitely not discuss them. You're speculating. You don't know why the results turned out that way. That's the idea behind doing statistical tests. And if it wasn't significant, general rule is it didn't happen. Discussing ambiguous data sources. I don't know how to say this better than what's here, but if your data is not conclusive, what you often see is people, when they're doing qualitative things, just discussing 1 or 2 statements from someone that they interviewed. Remember, you can massage any qualitative data, an hour and a half of discussion with someone. You can find almost always statements that will confirm or refute anything you want to confirm or refute. And also missing information, not discussing something that you actually found. There should be no holes here. Figures and tables. Remember, tables are lists of numbers or text in columns. They're made to make things clear so that people can compare and contrast different aspects of what you've done and what you've found. Figures, on the other hand, are visual representations of the results, or an illustration of a concept or a method, flowcharts, things like that. Within that, having said that, you have different types. You have graphs, you have images, you have diagrams. They're all used for different things. I could present a whole webinar on making use of figures. I think the best thing I can say to you is read Jim Hartley's book on making use of figures and tables and diagrams. He gives a good idea, but remember, there are different things for different graphs, different figures for different things. If you want to present a change across time, you'll probably want to use a line graph. If you want to present discrete information comparing groups, you'll probably want to use a bar graph. Choose the right figure for what you want to do. And finally, tables and figures should have captions, and they also need to be standalone. That means the person looking at the diagram or looking at your table should be able to understand the table or understand your figure without going back into the text, which means your title has to be good. If you make use of specific symbols and things like that, it should be presented in a note underneath it. You should not need to go between your text and your representation of it. Remember, all figures and tables should be referred to in the text. You should never present a table or a figure without referring to it in the text. Now, guidelines. Every journal has their own guidelines for here, but the most important, I think, are they should be high resolution, the labels should be neat and legible, they should be simple. Remember, if you're working in black and white and you have 7 different lines in a graph, making use of symbols or shades of gray, your reader will not be able to understand your graph. Keep them simple. Keep them clearly formatted so that everyone knows what the different aspects of your table or your figure is. Indicate sources of error within it, and give detailed captions. An important thing is, as I said, you should refer to your figures and your tables in your text, but try not to replicate data that's in your tables in the text. If you're presenting numerical information in your table, you don't need to say it in the text. If you present things in the text, you don't need to put it in your table. Keep them clean, keep them clear, keep them simple. I guess the rule of thumb is keep it simple, stupid. Then we have references. Usually, your references in an APA formatted text will precede your figures and tables, but here I presented it afterwards. The most important is check the specific referencing style of the journal. There's Cambridge style, there's Harvard style, there's Chicago Manual of Style, there's APA. They're all different reference styles. Make use of the one that your journal makes use of, and make sure there's a 100% concordance between the references that you've cited in the text and the references at the end, with the authors in the same order, with the years the same years. The most common mistakes is formatting, doing it wrong. Remember, APA has about 110 different specific reference aspects. An article with one author is different from an article with 2 authors, which is different from an article of 3 or more authors, which is different from an article with 7 or more authors. A chapter in a book is different from a chapter in a book that has been edited, which is different from a chapter in a book that has been edited that's part of a series, etc. Take a good look at the format that you should use and use the right format. A second one, especially for people in Europe, is not translating the non-English references. Your title of an article in French, Dutch, German should be followed by a bracketed translation of the title. A common mistake is that it's different in the text, that the A's and B's have been interchanged, that the year is the wrong year. Often made is that people forget the country, and if it's an American book, the state that the book has been published in. That's not always necessary. Paris New York. Those are places that are fairly unique, but Cambridge could be just as easily Cambridge, England, as Cambridge, Massachusetts. Check your style manual. And also, as I said, from the format, from the wrong type of reference. Referencing a report as if it was a published article. Now, the next kind of ending of your paper, of your manuscript, are the thank yous, the acknowledgements. That's the place that you acknowledge people who helped you, but not significantly enough to be included as authors. For example, is one or more colleagues might have proofread and commented upon your article. This is the place to thank them, but they're not a co-author. Those might be people who helped you during the experiment, teachers, proctors, colleagues, things like that. That might be people who helped with the analysis. Make use of second raters if you need an inter-rater reliability, people who transcribed protocols and things like that. You thank them, but they're not co-authors. And often in things making use of technology-enhanced articles, those who designed or developed a system used, the ICT people within your department. I mean, if you're doing a piece of design-based research on an environment, it's often the case that the developer of the environment could be a co-author. But most cases, this is the place to thank them. And finally, don't forget your funders. If you want to get funding again, include them here. The worst thing that you could possibly do, okay. One thing that you shouldn't do is finish it, have it printed, and then have your funder look at it and say, yeah, but I paid $500,000 for this, or €500,000, and they don't even acknowledge the fact that I gave them the money to carry out the research. You can forget about ever getting money again from that source if you've done that. This is a good place for a final check. It's also my last slide here. Check, is your paper, is your manuscript the right length? Before you send it in, if you fill in your IRS forms, there's also a final check. Did you include, did you include, did you include? The first is the paper the right length? Almost all journals will tell you what the average length of contributions is, what they accept and what they don't. It makes no sense to submit a manuscript to a journal in which they say the required or the suggested length is 4,000 words or 20 pages APA, to give them a manuscript that's got 8 or 9 or 10,000 words or is 40 or 50 pages long. Number one, it'll be sent back to you, but number two, the editor will probably think, why is this person sending it to me if they didn't even take the time to look at the requirements of my journal? Second, is it well organized? Does it have all of the parts that I discussed in the proper order so that a person reading through it understands what you've done, and knows why he or she should read it, has read it, and should take from it? Are the design and the analysis sound? Did you use the proper design to study what you wanted to study? Did you analyze it in the proper way? If the answer is no, it's a little bit late, but it's important to look at it. Do the conclusions follow from the results? Do you conclude something that you didn't find, or did you find things that you didn't discuss or make a conclusion about? Have you cited all relevant references and referenced all relevant citations in your text? Are all of the tables and the figures that you've used necessary? Remember, a table, while saving the number of words, usually is a half a page to a page long and is seen as equivalent to that many words by the journal. Are the title and the abstract fully descriptive of the text? If someone is looking for your article, will he or she find it based upon your title? Are there any ethical concerns with the research or paper? Did you use informed consent? Did you report upon this? Did you do things that you might not or should not have done? Or that you need to report that you did and that you took the proper precautionary steps? And finally, are the statistics proper and satisfactory? I mean, one of my pet peeves are people who give me averages of Likert scales when almost all methodology and statistics books will tell you that you cannot, should not, may not do that. Many colleagues do that. You'll find it in many, many, many research articles, but it's important to think about, have I done parametric tests on non-parametric data or the other way around? Thank you for listening to me, and I hope that this small webinar helps you in writing good manuscripts that'll get your manuscript eventually published.